Welcome back to the finance section. We are now going to talk about money and how that money can make you more money. And we're going to do this by way of example first to give you some experience with a problem, and then we'll come back in later and formalize it with math formulas and different math procedures. This first problem says Michal mows lawns during the summer to earn money. At the end of the summer, he wants to put $500 into a savings account for the next 3 years. The savings account at his local bank earns 4% interest each year, which is added to the balance of the account. Complete the table to find the balance that will be in the account at the end of each year. I'm going to go ahead and get us started with the first year, and then I'll have you continue. So we start the year with $500. Then to find the amount of interest, I'm going to do 4% of 500. So 500 times 0.04. This will be $20. The balance at the end of the year in the account is going to be that $500 plus the $20 in interest. So that'll get us $520. Now, the interesting part about this problem is it says the interest is added to the balance of the account. So the next year, instead of starting with $500, we're starting with $520. So now you can pause the video and fill in what would be in the account at the end of year 2 and the end of year 3. Then continue on and look at problem 2 and see what you can answer there. When you've completed problem 1 and problem 2, unpause the video and we will talk about it. So if you've done problem 1 completely, your answers should match mine. This problem is different than when we did simple interest because each year the principal, the amount that was in the account, changed. And this is what is called compounding. And in this example, we are compounding annually. Problem 2 says, is it possible to calculate the compounded balance at the end of 4 years? Yes, we can continue on. I didn't actually make a table for year 4, but at the end of the 4th year, the balance would be $584.93. The problem also asks, what about at the end of the 5th year? At the end of the 5th year, we would have $608.33. And then the problem says, can we find 10 years and 20 years? And yes, we can continue this problem on for a while. We could add more rows to our table and get our final answers. But maybe we could figure out a quicker way to do that. Before we do that, let's do another problem. When Michel goes to the bank, he sees a sign that says, our new savings accounts compound twice a year. This means that half the interest is added halfway through the year and the other half is added at the end of the year. So again, I'll do the first row to show you what that looks like. The interest earned in the first half of the year is going to be 500. Since we're only applying half the interest, we want to do half of 0.04, which is 0.02, and this is going to be $10. I'll add that 500 plus 10, and the balance at the half-year mark is going to be 510. Now, when I go into the second half of the year, instead of using 500, I'm going to use 510 times half the interest. That's going to get me $10.20. When I add $510 plus that $10.20, I get $520.20. Now, if we compare that to row 1 on the first table, you'll see that we already have a little bit more money. All right, now this is a great place to pause the video. Try your hand at row 2 and row 3. and then answer questions 4 and 5. So take a moment to do that. All right, now that you have worked through row 2 and row 3, your answers should match mine. Now, in problem 3, this is called compounded semi-annually because we compounded twice a year. The biggest difference to note is in both problems 1 and 3, we started with the same amount of money, $500, and we had the same amount of interest and rate was the same. However, our ending values at the end of 3 years are different. In the compounded semi-annually, we have $563.07. When we compound annually, we have $562.43. It may seem that it's not that big of a difference. If we were to increase our principal or increase our rate, the balance at the end of our term would be bigger. Problem 4 says, if the account is compounded 4 times a year, how do you think the balance will change? And as we saw here, when we increase the compounding, it gets larger. And the same thing would happen on problem 5. Instead of 4 times, if we did 12 times, then the balance will change. It will get even bigger. Now, going back to problem 1 and problem 3, all these steps became really tedious. And if we wanted to do it for any length of time, longer than a couple years, we'd run into a lot of calculations that would take a long time to do. So maybe there's a different way to do this. So now we're going to add our math notation. And here I like to change my pen color. I'm going to change to red so it really pops on my notes. And going back to problem 1, we can find that the balance, and I'm actually going to change this to future value when we get to the notes section on the next page. This will be equal to the principal times 1 plus the rate over the number of compoundings, all raised to the number of compoundings times time. And I'll define all those in just a minute here. So let's see if this works out on our calculator. The principal was 500 times 1 plus the rate all over the number of compoundings is 1 because it's annually, all raised to the 1 because that's what little n is, the number of compoundings times time. Now, if you put this all in your calculator, you will find that you get this exact answer. So we just need one formula to get the final answer. Let's write some more formal notes for this formula on the next page. The formula for compound interest is going to be FV equals P, the principal, times 1 plus the rate over little n, which is the number of compoundings per year, all raised to the n times t. All right, FV is going to be our future value. P will be the principal, or sometimes we call this the present value. R will be the rate as a decimal. T is going to be the time in years. And N is going to be the number of compoundings per year. We'll use this table here to the right to determine what little n is. For example, if a problem says it was semi-annually, like the problem that we did on the previous page, little n will be 2. Or if the compounding is daily, then little n will be 365. Let's go back to the previous page. The first problem said that it was compounded annually, which is why this denominator here and also the exponent had the 1, because little n was 1 compounding per year. In problem 3, this says that it was compounded semi-annually, so little n would be 2. So let's put this into our compounding formula. I will get FV equals 500, which is the principal, times 1 plus the rate, all over little n, and little n with 2, all raised to the little n, which was 2, times 3. In problem 4, it says if it's compounded 4 times a year, that means it's quarterly, and little n would be 4. For problem 5, it said it's compounded 12 times a year, so that means it's monthly, and little n would equal 12. Let's put everything together and do a problem. This problem says you just completed high school and received a lot of graduation gifts in the form of cash. The total amount you received was $3,000. You have saved $7,000 from your part-time job. Suppose you want to save your money for a newer car and decide that you're going to invest all the money for 8 years at an interest rate of 6.5%. If the interest is compounded quarterly, how much will you have for your next car? All right, first thing is we have $3,000 that we got in gifts, and then we already had $7,000. So this is our principal, and it is $10,000. Then we have the time is going to be 8 years. The rate is 6.5%. If I write that as a decimal, I get 0.065. Then here we have compounded quarterly. Compounding is little n, and quarterly, so think about 4 quarters are in $1, so 4 quarters in a year. Or if you're unsure, just check the table at the top of the page. Now it says, how much will you have for your next car? We want the future value of this account. So future value equals 10,000, which is our principal, times 1 plus the rate over the number of compoundings, which we said was 4, all raised to the 4 times the number of years, which is 8. When you put this in your calculator, you get $16,750.12. Now this is a good place to pause the video and put this in your calculator to make sure that you can get this result. Usually what happens is we get tripped up by the order of operation. So a couple ways you can attack this. One, some students like to put this all on one big long line in their calculator. That's totally fine, but you need to add extra parentheses in your calculation so the calculator knows exactly what to do. So if I were to enter this into a calculator in one big long line, I would put an extra set of parentheses around this fraction, and then I would put parentheses around this, and depending on the calculator and how everything was, I would even put parentheses around there. So if you're doing it all in one long line, that's how I would enter it. If you are doing it in pieces, I would do this fraction part first, then add the 1, then do the exponent, and then multiply by the 10,000. It's really a matter of preference how you do it. All right, now we have another question. This says, how much interest are we going to earn? To calculate the interest for this problem, we cannot use I equals PRT. The formula I equals PRT is for simple interest. This is not simple interest, so we can't use that formula. So what can we do? Let's think about what happened. We started off with $10,000 in the account. And that $10,000 just sits in the account and we do nothing to it. We just leave it there. When we come back 8 years later, we now have $16,750.12. So the difference between those is going to be the interest that was earned. $16,750.12 minus $10,000, because that's what I originally put in the account. We put in $10,000 and we didn't add any more. We just earned money from interest. So the amount of interest earned is going to be $6,750.12. Now you will see in your notes that there are several problems for you to check your understanding. I'm going to give you the answers so you know if you got it correct or incorrect, but make sure you're working these problems out, especially if you are in one of our online sections and you're submitting these notes. We do need to see the work. The answer to problem 1 is $16,796.69. The amount of interest is going to be $6,796.69. Problem 2, the answer is $16,819.50. The interest is going to be $6,819.50. There is going to be another video that shows you how to use this table and an app on the calculator to speed up your calculations. Problem 3 is just a question for you to observe what's going on between the example, problem 1 and problem 2. So I'll leave that there for you to answer. The answer to 4A is going to be $12,988.73. The answer to 4B is going to be $11,988.73. The answer to 5, PV, is going to be $1,872.91. The interest earned will be $1,532.91. And the answer to problem 6 is going to be PV equals $13,175.19. And that formula is the compound interest formula that we learned. It's also called the lump sum formula, which we will refer to it in our next section.